Hello everyone, hope everyone is doing good. So in this video I'm going to explain whole circle bearing and quadrantal bearing. So first of all I'm going to explain what is meant by whole circle bearing. So first I'm drawing the diagram. So from the diagram we can understand it very easily. As I already told in the before video, north, south, east, this is west. This is taken as A, taken as B, taken as C, and this is taken as D, and this is the point O. So what is whole circle bearing? The magnetic bearing of a line with respect to magnetic north measured in clockwise direction is known as whole circle bearing. These all are known as bearings. What are the bearings? A, B, C and D. A, B, C, D. These are known as bearings. So magnetic bearing of a line with respect to magnetic north. This is known as magnetic north. Means whenever we are taking these lines with respect to magnetic north, it is known as whole circle bearing. What is whole circle bearing? Magnetic bearing of a line with respect to magnetic north. Means everything we should take with respect to magnetic north. From magnetic north only we have to calculate. This is known as whole circle bearing. So first we are taking the whole circle bearing of OA. This is the line OA. So what is the whole circle bearing of OA? We have to take with respect to magnetic north. So like this. So this is theta 1. This is the whole circle bearing of line OA. Next, whole circle bearing of line OB. For calculating the OB, everything we have to take from the magnetic north only. This is O1. OB means this is the line OB. From here to here it is theta 2. Okay. Next, whole circuit bearing of line OC. For line OC, whole circuit bearing is taken as this is the whole circle bearing, that is theta 3. Next, whole circuit bearing of line OD. For line OD, whole circuit bearing is taken as theta 4. This is the whole circle bearing of line OD. Okay, hope you understand. Every whole circle, in case of the whole circle bearing, we have to take only with respect to magnetic north. With respect to magnetic north, this is theta 1, this is theta 2, and this is theta 3, and this is the theta 4. By using this we can calculate the angles. This is about the whole circle bearing. Next, our second one is quadrantal bearing. Another name for quadrantal bearing is reduced bearing. Okay, QB or RB. In this case also, first I am going to draw the directions: north, south, east, west. This is point O, OA, OB, OC, and this is OD. Okay, what is quadrantal bearing? The magnetic bearing of a line with respect to magnetic north or south, whichever is nearest to line measured in clockwise or anti-clockwise, is known as quadrantal bearing. I have forgotten to say, in case of whole circle bearing, we are only taking the clockwise, only we are taking the clockwise movement. In case of the quadrantal bearing, this is also the magnetic bearing of line. In this we can take with respect to magnetic north, or we can take with respect to magnetic south. Means we can take with respect to north direction, or we can take with respect to south direction, whichever is nearer. In this it may be clockwise or anti-clockwise. Same, magnetic bearing of line with respect to magnetic north or magnetic south. In this it may be clockwise or anti-clockwise, whichever is near. This is known as a quadrantal bearing or reduced bearing. So for finding the quadrantal bearing of line OA, for line OA the quadrantal bearing is Which is nearer to north can be taken north or south. Which is nearer to north? East. So north, east. This is the angle. Next, quadrantal bearing of line OB. South, east. Quadrantal bearing of line OC. South, west. Quadrantal bearing of line OD. North, west. If there is any angle, this is theta 1, theta 2, theta 3, theta 4. We can take in a north, theta 1 east, south, theta 2 east, south, theta 3 west, north, theta 4 west. So this is about the quadrantal bearing or reduced bearing. So what is the main difference between whole circle bearing and quadrantal bearing? In case of the whole circle bearing, we are taking only with respect to magnetic north and only in the clockwise direction. Whereas in case of the quadrantal and reduced bearing, we can take with respect to magnetic north or we can take with respect to magnetic south. It may be taken in case of in clockwise direction or anti-clockwise direction. Thank you everyone.